All right, let's get right into it. Today, we are going to break down the 8 most important RAG architectures that are really powering modern AI. We're going to see how these systems find information, how they think about it, and how they scale up to handle the messy, real world. When most people hear about RAG, retrieval augmented generation, they picture this really simple straight line. A question goes in, some documents pop out, and an answer gets written. And hey, that works until it doesn't. And that's really the core idea for today. As our AI systems get bigger, as the data gets way more complicated, and as we demand almost perfect accuracy, well, that one simple RAG approach just isn't going to cut it anymore. It's why we have to think about architectures, not just a single feature. So here's our game plan. We're going to start with the absolute basics, what we call naive RAG. Then we'll level up, looking at architectures that handle much richer context, and even some that can reason and adapt all on their own. We'll end with a toolkit that'll have you thinking like a top-tier AI engineer. Okay, let's start at square one, the foundation that everything else is built on, naive RAG. So what is it really? At its heart, naive RAG is beautifully simple. It just looks for documents based on how similar a user's question is to the data it has stored. It's a direct comparison of meaning, nothing more. And the process is a pretty clean 3-step dance. First, the user's question gets turned into numbers, an embedding. Second, the system hunts through its database for the document vectors that are the closest match. And finally, it feeds those documents to the language model to whip up an answer. Simple, clean, direct. And you know what? That simplicity is its superpower. Naive RAG is fast, it's cheap, it's easy to set up. That makes it absolutely perfect for things like quick fact-based questions, searching through documentation, or powering a simple FAQ chatbot. But here's the catch, and it's a big one. Naive RAG assumes that the user's question and the best answer are already pretty close in meaning. So what happens when they're not? This is where things start to break down, and where we need to get a lot smarter. All right, let's move on and see how RAG evolves to deal with richer context. This is all about tackling 2 huge real-world problems, all the different kinds of data out there, and, let's be honest, some pretty bad user questions. The first big leap is multimodal RAG. See, naive RAG lives in a text-only world, but real-world data is messy. It's got images, audio clips, videos. Multimodal RAG uses special models that can understand all these different formats, so your text question can pull up the perfect diagram, a screenshot, or even a clip from a video. Okay, so we've handled different data types. But what about the user's question itself? People ask vague questions, or super short ones, or they just don't use the right keywords. This creates what's called a semantic mismatch, and it can totally stump a simple RAG system. And the solution here is so clever. It's called hypothetical document embeddings, or HyDE, and it pulls a really cool trick. Instead of using that fuzzy, vague user query, HyDE asks the language model to imagine and generate a perfect hypothetical answer first. Then it uses that ideal answer to find the real documents. Why? Because that fake, perfect answer is often way closer to what you're actually looking for than the original question was. So we're getting way better at finding stuff. But finding something and trusting it are 2 totally different things, right? What if the data is old, or what if 2 sources say the exact opposite? In high-stakes fields, this is a massive problem. And that's where Corrective RAG comes in. Think of it like a fact checker built right into the system. After it retrieves some info, it double-checks it against trusted sources, maybe even a live web search. If it finds something that's wrong or out of date, it corrects it before it ever generates an answer. This is absolutely crucial for finance, for medicine, for law, anywhere accuracy is non-negotiable. So far, we've improved our context and our accuracy. Now, we're going to get into the really smart stuff. Let's move on to architectures that don't just find things, they actually reason and adapt. This is where AI starts to feel truly intelligent. In this advanced tier, we've got a few heavy hitters. There's Graph RAG, which builds knowledge graphs to understand the relationships between things. There's Hybrid RAG, which is a mix-and-match approach. It combines vector search, keyword search, you name it, to get the best of all worlds. And then there's Adaptive RAG, which is super efficient. It looks at the question first and decides if it needs a simple search or the full, complex treatment, saving a ton of time and money. And that brings us to the top of the mountain, Agentic RAG. Seriously, this isn't just a pipeline anymore. It's an autonomous system. You have AI agents that plan a strategy, use different tools, check multiple sources, validate what they find, and then do it all over again until they're confident they have a great answer. It's like having a tiny autonomous research assistant. Agentic RAG is always thinking. It operates in this constant loop. First, it plans the best way to tackle a problem, then it goes out and retrieves info using whatever tools it needs. It validates everything it finds, and then it refines its search and starts again if it has to. This iterative reasoning is what lets it handle incredibly complex tasks that would be impossible for any of the simpler models. Whew, okay, we have covered a lot of ground. Let's pull this all together into a practical toolkit, because at the end of the day, it's all about knowing which tool to use for which job. This chart right here, this is basically your cheat sheet. If you need pure speed for an FAQ bot, you grab Naive RAG. If you're building a financial tool where trust is everything, you need Corrective RAG. And if you need an AI to do complex, independent research, you deploy an Agentic RAG system. See? Every single architecture is a specialized tool for a specific kind of problem. So if you remember one thing, let it be this. RAG is not a feature you just flip on. It's a system design philosophy. There is no single best RAG. The whole goal is to really understand the problem you're trying to solve and then pick or even combine the right architectures for the job. And just like that, you now have a solid grasp on the 8 major RAG architectures that are defining the cutting edge of AI systems today. And what that really means is you're not just thinking about the language model anymore. You're thinking about the entire system, the retrieval, the reasoning, the whole shebang. You are now thinking like a real AI systems engineer. And I want to leave you with this one last thought. As AI continues to move out of the lab and into the real world, the quality of our retrieval is becoming even more important than the size of our models. The future of AI isn't just about building bigger models, it's about building smarter, more sophisticated retrieval architectures.